So I was thinking about this. The universe, if somebody were to ask you the universe today, what it is, you would say, well, the universe is the galaxies, and we know that we believe that actually there's an edge to our universe where the fabric of space and time is expanding into nothing, no space and time, but that's our universe. But actually, and that still works, but the universe at the time, we're kind of talking like way back when, at the time of Aristotle and the Greek philosophers, that universe is still our universe. So the universe is all of the matter and all the energy that is. And actually Newton would throw in, Einstein would throw in there the space and time that matter exists as a part of is actually part of the universe. But anyway, kind of still going back historically, Greek astronomers could actually observe planets moving. So the two inner planets, of course, Mercury and Venus, and then the Mars. Okay, and Earth, that would be 4 terrestrial planets, and they could also see Jupiter and Saturn. Okay, so they could actually see 5 planets moving against the background stars. Now, we'll be talking more about that, but these planets, they move on what we call the ecliptic, okay? The plane of the ecliptic that holds the Earth's orbit as it orbits the sun is very similar, or to the plane that holds the other planets. So it's like one big happy record player or frisbee. But so they would actually see these planets move. Generally, they'll move eastward. They still move today. Generally, planets, night after night, you see them move eastward against the background stars. So you have to pick a constellation they're in and then go out over the next week or so and watch that planet move eastward against those background stars. Now, a constellation will rise at like 4 minutes earlier each night. So the time that you're going to look at that constellation, it will be a different location in your nighttime sky. But so I'm amazed that actually these budding scientists actually would mark where those planets are against the background stars. So eastward is what we call direct motion, and actually then westward is retrograde motion. We talked about that at the end of chapter 2. So this is chapter 3. So we introduced this sort of apparent retrograde motion, this westward motion against the background stars of the planets. Planets are moving. And so, again, also introduced at the end of chapter 2, this direct motion. Okay, direct motion can be explained with a geocentric model. Remember, geo means Earth, so Earth in the center model. So actually the normal motion of the planets can be explained if the planets are orbiting the Earth. I know, it's strange, right? Okay, so retrograde motion then can be explained, like we said, that backward motion, if we go ahead and put the sun in the center of the planet's movements. So the Earth orbits the sun as well as the other planets orbit the sun, and then we can explain retrograde motion. Remember, that was where at the end of chapter 2 we said retrograde motion occurs as a planet overtakes the other planet. So actually, just to kind of, I'm going to show you a famous person with a geocentric model called Ptolemy, but before I do that, let me point out that as early as 260 BC, Aristarchus was a proponent of the heliocentric model, the sun-centered model. So here we go. Here's Ptolemy. And so Ptolemy, I like to think of it, I'm not sure it's true, but I like to think of the Ptolemaic model and Ptolemy as being kind of last gasp for this whole Earth being in the center of the planets orbiting the Earth, the sun orbiting the Earth, the stars orbiting the Earth. You kind of get the idea. But what Ptolemy did, which was significant, was he actually came up with an explanation for why those planets appear to go backward. Why is that apparent retrograde motion of the planets? Why does that happen? And so what he did, actually, it's kind of cute. Here's a little map of what Ptolemy did. He created these little loop-de-loos, okay? Ptolemy created these epicycles. So here's an epicycle, epicycle, epicycle. So the way these work is a planet is going, planet is going in its orbit. See if it'll go. Yeah, there it goes. Planet is going in its orbit. Okay, and then here it falls into an epicycle. It goes around, okay, and then it goes. Now here's the deal. Right here, I don't know if you can see it, right here-ish, this is where it was going retrograde. Okay, so it actually would go retrograde at the center of all of these epicycles. Other than that, it was going direct. So those are little epicycles, and that's what the Ptolemy model is, Ptolemaic model. Ptolemy came up with those. Now, near the end of chapter 3, I have a slide to kind of introduce things of what things that are tall tale signs that this is a true sign, or this is the right explanation. Okay, so explanations in science are best if they are simple. It's called Occam's razor, and to me, this model is not simple. So just to kind of remind you, kind of the basis of all science usually is pretty steeped in tradition, but is steeped in others coming before us. And actually in astronomy, like I said, the Middle East was very much a place to go ahead and maintain the knowledge, especially like you see on this slide during the Dark Ages. Many of the stars, even now, when we look at their proper names for stars, they are Arabic names, which is kind of cool, and that's not by accident.